The lesson today is on circles, and oftentimes students ask, when will I ever need this? And I'll just give you a brief explanation of why circles are helpful. Suppose you buy yourself a car and you find that you need some new tires in the car. So here you are in your wonderful new machine, riding along, and pretty fancy vehicle here. You decide to go to the tire store, and they don't have any circular tires. They just give you triangular and rectangular tires on your car. You would soon realize as you're driving down the road, you wish you would have circular tires on your car. So you will need circles for your car, if for nothing else. You also have to tell them what size tire you need, and that has to do with the diameter of the tire. So that's kind of important to know. Vocabulary here of a circle. So let me try to construct one here. And this is going to be kind of intuitive. We'll go into some more details tomorrow. So, definition of a circle has to do with the center, and it's a continuous set of points that are all the same distance from the center. So it's going to got curves to it. As you go around, all the points are equal, all the same distance from the center. And that if you drew a line segment from the center of the circle to a point on the circle, and you label that segment AB. And don't forget the little segment over there, that would be a radius. And if you go all the way through the circle, from a point on the circle, through the center, to another point on the circle, that segment is a diameter. And if you go from a point on the circle to another point on the circle, and you may or may not go through the center, you don't have to go through the center, and we'll call that EF. EF is a chord. If you take the area inside the angle that's formed by radius AB and AC, that section is called a sector. And CB, if we get from C to B, that's called an arc. And that's arc CB. So here's the terms we talked about. We talked about going from a point from the middle of the circle, the center of the circle, to a point on the circle being a radius. It's supposed to be an S, sorry, it's pretty bad. And from a point on the circle, going through the circle, and also through the center, that's a big deal. That's diameter. And then on the circle to another point on the circle is a chord. All diameters are chords because they go from a point on the circle to another point on the circle. So by definition, they're chords. I forgot to mention that this angle that's formed by C to A to B is referred to as a central angle. Angle CAB is a central angle. It has the center of the circle as its vertex. So that's the definition of central angle. Be able to figure out the area of the circle. There's an important ratio in circles. If you take the distance around a circle, which is called the circumference, if you just go around, it's called circumference with a capital C. So pick a point here and just start going around it. That's the circumference. It's a little like perimeter of a polygon, but you don't use the word perimeter for circles. You use circumference. So circumference is distance around a circle. And then if you took the circumference and divided it by the diameter, you'd always find that that's equal to about 3.14. It's actually referred to as the Greek letter pi. 3.14159. It's an irrational number. It goes on and on forever. So we can say there's one of the formulas right there, that circumference divided by diameter equals pi. You can multiply both sides by diameter. This would cancel, and it leaves you with circumference equals to pi times diameter. And since diameter equals double the radius, where we have diameter, we could put in 2r, circumference equals pi times 2 times the radius. Then we can change the order of that and say circumference is 2 pi r, which is a very common way to represent the formula, along with circumference equals pi times diameter. So if you know the radius, you can plug it into this formula and do double pi times the radius. If you know the diameter, you can just do pi times the diameter. And you can use your calculator to do these calculations, it'll use a very more precise value for pi. And the other important formula is that the area of a circle is equal to pi r to the second power. And if we have time in class tomorrow, we'll look at a sort of a logical reasoning way to understand why this formula works. It's pretty easy to kind of split the circle into different sectors and then rearrange them to show how this formula works. So this is a very quick idea. We'll spend a lot more time in class using the formulas. We're not going to show you much about that in this video. I just want you to come into class familiar with the formulas and familiar with the terminology.